So the first model we have is the geocentric model. The geocentric model is basically where they thought the Earth was the center of the solar system, and then the Moon, Mercury, Venus, the Sun, Mars, Jupiter, and Saturn all revolved at the same speed in a circular motion around the Earth. And this was the earliest idea and the most accepted thought of the solar system. The heliocentric model, or the Copernicus model, was where the updated model where Copernicus started to relay the facts that the Earth is not the center of the solar system, but the Sun is. And the order of the planets would go Mercury, Venus, Earth, but the Moon revolves around the Earth, Mars, and then Jupiter and Saturn. And he also found out that all the planets do not move in a circular motion, and they do not move at the same speed.
So for Kepler's first law, it's all planets travel in elliptical orbits. So every planet travels in an elliptical orbit, but not all of the orbits have the same eccentricity is basically what that means. So for the second law is as a planet becomes closer to the sun, the speed of the orbit increases. So for example, Mercury would have the fastest orbit because it's closest to the sun, and Neptune would have the slowest because it is the farthest away from the sun. And then for the third law, it's the distance from the sun increases, so which means the length of the orbit does as well. So for example, Mercury is 80 days and Neptune is 165 years, and Mercury is the shortest and Neptune is the longest.
Newton's 3 laws of gravity. The first law is that objects will not change its motion until acted on by another force. So if I had something that I threw, it will continuously keep going. Let's say in space, it will, like an asteroid, it will keep going on the same path until it is acted on by another force. Let's say another asteroid hitting it, or it hits like another planet or something. And the second law of Newton's gravity laws is that the force of an object is equal to mass times acceleration. So basically, how big something is and how fast it's going determines on how much force or like the object. His final law is for every action, there is an equal and opposite reaction.
So our first astronomer we're talking about is Taikyo Gray. He was a Danish astronomer, and he found errors in planetary positions. So one of his biggest achievements is tracking the motion of a comet, and he showed stars and planets have no angular shift compared to stars, as our position hit with the rotation of the Earth, meaning that the Earth is not still. And then he built the first modern observatory, which led to more astronomers throughout the world. And he also created the Ray model, which is basically just the all planets orbit the sun, and the sun orbits the Earth.
Isaac Newton is our second astronomer, and he discovered calculus. He discovered the 3 laws of gravity, which we said earlier were that objects in motion will not change until acted on by another force, and then the force of an object is equal to mass times acceleration, and then that every reaction is an equal and an opposite reaction. And he improved the telescope so we could see different details of the Earth, or not the Earth, the solar system, and everything like that.
Okay, so our third astronomer is Kepler. So he basically found the motion of the planets are not the same, and he studied the orbit of Mars and found it to be elliptical, meaning that each orbit wasn't an exact circle. So this led to the discovery of eccentricity, and astronomers studied the exact orbits of the planets because of the new knowledge that each planet's orbit is not a perfect circle. So the 3 laws that Kepler created were of planetary motion were all planets travel in elliptical orbits. The closer to the sun, the faster the orbit, and the farther from the sun means that it takes longer to orbit the sun.
Okay, and our fourth astronomer is Nicholas Copernicus, and he was a Polish astronomer, and he put forth the theory that the sun was actually the center of the solar system. It can be called the Heliocentric model, or commonly called the Copernicus model, because he was the one who started to change society's opinion on and giving facts about how the sun was in the middle, not the Earth. And then he also found that the Earth is spinning on an axis daily, and then it revolves around the sun. And he also kind of changed the role of astronomy in a society, making more people interested and wanting to learn more about the stars and the solar system.
So our fifth and final astronomer is Galileo. So he was a pioneer for observational astronomy. He also found the evidence to support Copernicus' theory of a centered solar system, of the center of the solar system is the sun. And he as well created the idea of an improved telescope to study the sky, stars, and planets. He observed the moon's geological features such as dark spots and craters, and discovered the four moons of Jupiter as well.